Okay, so today we're starting the second unit, and it is about conditional statements. There's a lot of writing with this section. So just some vocabulary, and you will have all of this on your cheat sheet. A conditional statement is a logical statement that has two parts, a hypothesis, P, and a conclusion, Q. When a conditional statement is written in the if-then form, the if part contains the hypothesis, and the then part contains the conclusion. So if you're going to use this in words, if P, then Q, and the symbols are P and then an arrow going to the Q, and it's read as Q implies P. So to write a converse, this is the next one, a converse of a conditional statement, exchange the hypothesis and the conclusion. So you just switch them around. So if Q, then P, or Q implies P. To write the inverse of a conditional statement, negate both the hypothesis and the conclusion. And we're going to get into what negate means in a little bit, but it's kind of like opposite, but a little bit different. So the words would be, if not P, then not P. Or if not P, then not Q. To write the contrapositive, that would be whenever you switch them. So it's like the converse and the inverse put together. So if not Q, then not P. So then the symbols are not Q, then not P. Okay, so now this next part, we're going to be identifying the hypothesis and the conclusion. So let's do yellow, let's do green for the hypothesis, and I will do pink for the conclusion. So all 30 degree angles are acute angles. So the hypothesis would be 30 degree angles, wrong color, 30 degree angles, and then the conclusion would be acute angles. So then they want you to write it in the if-then form, so this might make more sense to you. If an angle measures 30 degrees, then it's an acute angle. And that is a true statement. This next one can be a little tricky. So 2x plus 7 equals 1 because x equals negative 3. So this one is actually backwards. The hypothesis comes first. So if x equals negative 3, then this is true. So if x equals negative 3, then 2x plus 7 equals 1. All right, so now let's talk about the negation. So the negation of something is saying it's not true. Okay, so dogs are the worst pet. So it would say dogs are not the worst pet. It's not saying they're the best. That's not what it's saying. So don't think opposite. It's just saying they are not the worst. So Mrs. Roeder smells bad. So this would be Mrs. Roeder does not smell bad. Okay, next page. So now writing conditional statements. So let P is going to be you're in New York City, and Q be you're in the U.S. Write each statement in words and decide whether it is true or false. So the first one is just the regular conditional statement, if P, then Q. So this would be, if you live in New York City, because that's the P, comma, then, oh, sorry, not live, if you are in New York City, then you are in the U.S. Okay, is that a true statement? Yeah, it is. It's going to be true. Okay, the converse is going to be the opposite. So, if you are in the U.S., comma, then you are in New York City. And that would be false. Because it could be true, but it's not always true. Okay, so the inverse, so this is the negation of P then Q. So if you are not in New York City, then you are not in the U.S. And that's not necessarily true either. It could be, but it's not always true. So that's going to be false. And then the contrapositive is the negation, but then they're flipped. So Q then P. So if you are not in the U.S., comma, then you are not in New York City. Okay, so that's true. If you're not in the U.S., you're definitely not going to be in New York City, so that will be true. All right, so now using definitions to just explain if the statement is true. So, I mean, explain your reasoning. So, first of all, in this AC, let's go ahead. I can't get Google Docs to make the line symbols. So, let's go ahead and write those in. So, those are line segments. Or not segments, they're lines. So, line AC, and that little symbol right there is the sign for perpendicular. So, is AC perpendicular to BD? And it is, so that would be true because of this little right angle right here. So, so let's talk about this. Let's see if all of these angles are 90 degrees. So let's first talk about vertical angles. So vertical angles, the vertical angle to that one would be this one right here. And vertical angles are equal. So if there are two lines intersect, it's the angles that are across from each other. So those both have to be 90. And then let's talk about this line. So this is a straight line. It is 180 degrees. If this is 90 and the whole thing is 180, then this has to be 90 as well. And it would go the other way as well if you looked vertically. And then if they're vertical angle to that, or you can just say they're supplementary, all of those angles are 90 degrees. So those two lines are perpendicular. And how you would say that is true, because the right angle symbol tells us, if I can write, they are perpendicular. Okay, then let's talk about AEB and CEB are a linear pair. So AEB, that is the one with the right angle symbol. So AEB and CEB, so that would be this one, are a linear pair. So just to recap, a linear pair is two angles that add up to be 180, so they're supplementary, and then they also have to be adjacent. So they're on the same line, and they add up to be 180. And so are those two? Yes, that would be true, because the angles, just like I would say in the definition of a linear pair, the angles are adjacent and supplementary. Or you could say they are adjacent and they lie on the same straight line. Whatever, it's the same thing. Okay, now let's talk about ray EA, and let's draw a ray symbol. Again, Google Docs won't let me do that. So EA and EB are opposite rays. So EA is right here, and EB would be right here. Those are obviously not opposite rays, so this would be false because they're not going in opposite directions. And in order for them to be opposite rays, they would have to be on the same line, so they are not on the same line. Okay, let's talk about biconditional statements. So, a biconditional statement is when a conditional statement and its converse are both true. So if you can go P then Q and then Q then P, then you would use if and only if. So that's how you would write it. And then there is the symbol. It's a true line, so with two arrows. So if an angle is a right angle, then its measure is 90 degrees. So are those true? If it's a right angle, does it measure 90? Yes. If it measures 90, is it a right angle? Yes. So how you would write this, an angle is a right angle comma, if and only if its measure is 90 degrees. Okay, if two line segments have the same length, then they are congruent segments. So if two line segments have the same length, then they are congruent. That's true. Then say it the reverse. If they are congruent segments, the two line segments have the same length. Yes, but they mean the same thing. So it's just different ways to say it. So we're going to write with if and only if. Two line segments have the same length if and only if they are congruent. And you could say the reverse. That would work too. So if Mary is in theater class, then she will be in the fall play. If Mary is in the fall play, then she must be taking theater class. So they're telling you right off the bat that it works both ways. So there's no confusion. So then this would be Mary is in the fall play. If and only if she is in theater class. All right, so I know this lesson is a little bit weird because it's not just basic math. You really have to think and slow down a little bit. So just take your time, be open-minded, try not to shut down because I know it's not the most fun lesson. I feel the same way, but we're going to get through it. Thanks for watching.